Motor drive technology. Hey everyone, ever wondered what powers your electric vehicle? It's not just about batteries. There is a more revolution happening under the hood. Today, we are diving into seven main motor technologies driving the EV world forward. Let's go. DC brushed motor. Let's start with the OG, the DC brushed motor. Remember those toy cars from the 90s? Yeah, same technology. These motors have high torque at low speeds, but they are bulky, inefficient, and high maintenance. You have got brushes that wear out. Not ideal for modern EVs. They had their time, but now mostly history. Brushless DC motor. Enter the brushless DC motor. Smaller, cleaner, more efficient. No brushes, so less maintenance, high power density, quiet operation, and found in everything from scooters to drones to young EVs. And with Hall sensors and smart control systems, they are even more optimized today. Induction motor. Up next, the induction motor, invented by Nikola Tesla himself. These babies ruled the EV scene from years. They are rugged, cheap, and low maintenance. Plus, they work with simple inverters, adjust to the frequency, change the speed. Easy. But now they are slowly being replaced in high performance EVs. More on that later. Synchronous reluctance motor. Okay, here's a technology one, the synchronous reluctance motor or SynRM. This one operates on reluctance torque. Basically, it wants to follow the magnetic path of least resistance. High efficiency, simple design, and low cost. It's simple strong candidate for plug-in hybrid and fuel cell use. But the power factor still needs to be worked on. Switch reluctance motor, SRM. Ancient technology, but super tough. No magnets, so no risk of demagnetization. Simple rotor, complex control. It's loud and has low power density. But with new converters and hybrid systems, it could be great for smaller EVs. Permanent magnet synchronous motor. Here comes the big player, the PSM, permanent magnet synchronous motor. These are everywhere. Teslas, hybrids, you name it. Why? High torque, compact size, and great efficiency at various speeds. There are two types, surface and interior magnets. They need careful monitoring, but manufacturers love them. Flux reversal motor. And finally, the flux reversal motor, the new kid on the block. Think of it like a hybrid. It uses both permanent magnets and stator windings on the same teeth. High torque, great efficiency. Low power factor though, and potential demagnetization if not designed right. But hey, innovation always starts somewhere. Thank you.